React can pause mid-render, throw away half-finished work, and pick up a completely different task or a new task without you even writing a single line of code for it. And here's how. In React, we change the state, then React uses that state to create a new virtual DOM and then compares it with the old virtual DOM and via the differing algorithm and then applies the update. All this happens by walking down the tree. It basically finds out what has changed and then applies the changes. Now, the process of finding the difference between the old tree and the new tree is what we call reconciliation. So, how did reconciliation work before React Fiber was introduced in React 16? It usually use an algorithm similar to a DFS algorithm, and the code roughly looked like the one you see on the screen. So it was entirely based on recursion. Now the problem with recursion was that once JavaScript entered the recursive process, there was no way to get out of it without completing it or discarding the entire process and then giving up on it. There was no possibility to pause the execution and then recontinue it, or to pause the execution works for some to cater to some priority work, and this was usually fine until there was some work that came up due to that required a lot of computation or the work that took a few seconds. Now this created the problem because the screen froze for the whole time the React was stuck in that work, you know so like not even the click on an input element would work and the entire application would freeze, like not even the scrolling would work for the time. So React in browser runs on a main thread and it is responsible for all the different things like processing clicks and handling all the asynchronous events like keyboard input and other stuff like calculating layout and paint and all that sort of stuff. So if React is stuck in the render work, then all those things are stuck too. So while building a front-end applications, we need to prioritize user experience first. So there are certain things that are related to user interaction that must be given priority over the slow rendering or computation work. Let's take an example of a challenge that I faced. Back in my early freelancing days, I built a search dropdown that had to cover every job title in the world. Like there were thousands of them in the database, and the backend developer forgot to put like a limit on the search API. Right, and the backend developer was also me. So as soon as I tried to search a job in an input, suppose with the character A, the API would return thousands and thousands of titles, making the entire input element stuck for a few seconds until the render work was done. So if I input something else, then the input element would not work and the application would feel stuck. Now to solve this by adding a limit to the API is an obvious solution. But what if we want to solve this on the front end side? This was just one highly computational work. What if suppose there was another work that would require that much of amount of computation and we want to stop it between, like it would make the entire framework or the entire page that we have, it would make that page stuck, right? So to solve this problem, the React Fiber was introduced. So in the legacy recursive algorithm, the position at which the execution is currently located at was in the call stack, and the call stack is just filled up of nested JavaScript functions. So there was no way to keep track of the current execution process and what needed to be processed next and what are the things that has already been processed. To solve this exact problem, React Fiber was introduced. Now, what if instead of treating the entire tree traversal in a one as a one huge recursive operation, we could break the work into multiple smaller units that could be traversed instead of recursion. So each component in a React tree can be represented by something we can call as React Fiber, Fiber node, and the Fiber node can keep track of everything what a component is currently processing, its parents, its children, its siblings, and so on. So every fiber node need to contain enough information to help React manually navigate the tree without recursion. For that, every fiber node mainly has three important links: the child link, the siblings link, and the return links. The child links tells React where it needs to go deeper, and the sibling link tells React what needs to be processed next on the same level, and the return link points back to the parent. Now, then using all of that, the navigation becomes quite simple. If the fiber has a child, go to the child. If it does have not have a child, then check whether it has sibling or not. And if it has a sibling, then go to the sibling. If it does not have a sibling, then we have basically traversed it and to go and return back to the parent and keep moving upward, until a sibling is found. So now React can keep track of all of that using fiber nodes. The entire execution can be divided into units of work. So let's consider each fiber node a unit of work. So after each unit of work, React can basically go and check whether some priority work has came that needs to be executed or not. So if some priority work has come up, then it can stop the current work, do that work first, and then maybe continue or discard or restart the current work. But then who decide when React should stop? After each unit of work, it has to answer one question. Do I keep time? Do I have the time to keep going, or should I hand the control back to the browser? This is where the scheduler comes in. The browser wants to paint a new frame regularly every 16 milliseconds. Inside each of those windows, it has to run a JavaScript, calculate layout and paint and all that stuff. So if React grabs the thread and it does not let go of it, the browser blows past the budget and misses the frame, and that is exactly why the screen feels stuck. So the scheduler's whole job is to give React a small slice of time to work and make sure React gives the thread back before the browser needs it. So React's work loop is basically this: keep processing the work as long as there is time left and there is still work to do, right? So the moment times run out, the loop exists, and the React stop mid tree, and the control goes back to the browser to do the handle any async work or handle the paint or the keystroke or all this sort of stuff. So when there is idle time again, it picks up the exact React Fiber node where it left off, because the position now lives in the React Fiber tree, not the call stack. So you can continue where you left it, or you can discard the whole tree and start again, based on what has changed. So the React team created its own scheduler package. It assigns different priorities to different things, such as, for example, user typing is actually urgent, while the data loading in the background is not. So the scheduler can basically rank the work, so an urgent update can jump ahead of a slow render that is already in the progress. So going back to the drop down example, if we work on rendering thousands of titles can now be interrupted. The moment user types in an input field, React can pause the render, uh, handle our input first, and stay responsive, and then continue the work later. There are many features in the current React version that are powered by React Fiber, such as useTransition, which basically let you mark a piece of work as a non-urgent, so it can be interrupted. Exactly what my dropdown needed, right? So, and many other things there are that are also powered by React Fiber, such as automatic batching, suspense, and concurrent rendering, are all powered by React Fiber internally. So that is the real takeaway. All of these features are standing on a single idea that I told you about. So this is the whole point of the channel, to go one level deeper than it just works. So see you in the next one.